everyone, I'm Sammy and welcome to SPMS. Today, I'll be bringing you on a lab tour around the physics department of SPMS. So come on, let's go! Right now, we are at the cold atoms and quantum sensing lab. So now, let's go and check it out. Hi, Dr. Chan.
Hi Sam, nice to meet you.
So I noticed you'll be doing some work just now. Perhaps please share with us what kind of work do you actually conduct in this lab?
We perform quantum science experiments with ultra-cold atoms inside a hollow core fiber.
Oh, I see. That sounds very interesting. So how do you actually cool these atoms?
We use laser cooling and trapping techniques to slow these atoms down from the speed of jet airplanes to the speed of a crawling snail. And in doing so, we reduce their temperatures from room temperatures to temperatures colder than outer space.
Outer space? Isn't that very cold? Okay, so I've been wondering what happens when these atoms are slow enough?
When the atoms are slow enough, we will catch them and put them inside a bottle made of electric fields from these laser beams and magnetic fields produced by these coils over here.
I see.
And once we have billions of these atoms, we will funnel them into our fiber, which is thinner than the size of a human hair. I actually have a piece of this fiber for you today.
Oh, wow. Let's have a closer look at this fiber. And indeed, it's very thin. Alright. So, Dr. Chen, you have just mentioned about how you're able to cool these atoms and how these fibers are being used. So I'm wondering, how can this kind of work impact our daily lives?
We hope that by improving our accuracy and precision, one day we can produce a highly accurate and compact inertial navigation sensor. So for example, you can think of that as having GPS inside indoor environments or even underwater.
Oh, that sounds very interesting, and I'm very hopeful to see this in the future. So thank you, Dr. Chen, once again.
Thank you.
Thank you. So just now, I had a very interesting and enriching experience talking to Dr. Chen and learning more about the work that is being conducted in this lab. So right now, let's check out the next lab. Currently, we are at the Center for Disruptive Photonic Technologies, which is a world-leading research center that is engaged in developing the next generation of optical and photonic technologies. So right now, let's go in and have a look. Now that we're all geared up, let's take a closer look at this lab. Today, we have Shruti with us to share with us more about this lab. Hi Shruti!
Hi Sam!
Hi, so could you tell us more about this lab?
Sure. We are standing in the nanofabrication prototyping clean room of CDPT, and CDPT was founded in 2012 by the grant from MOE Tier 3.
Alright, I see. So I was very curious. When I came in, I had to wear this full bodysuit.
Yes,
so is
that's
there actually
true.
a reason for us to do so?
Yes, because we work with a lot of sensitive samples around, so it is required that we gear up so that we do not contaminate our samples.
Oh, I see. So I actually noticed that you're working with some samples and doing some work here.
Yes.
So could you elaborate on what work you do in this lab?
Sure. The focus area of our lab is to work mostly in the direction of photonics, and we end up looking at things down to the atomic level and also fabricate stuff which is almost nanometer size.
Oh, that sounds really interesting.
Yes, it is.
So I'm just wondering if there has been anything interesting in this lab or any experiences that you have faced so far?
Sure. As an analogy, if we can think of etching our name on a grain of rice as small, the things that we do in this lab are almost 1,000 times or more smaller than that. So you can imagine how much minute everything it gets in the lab.
I see. Okay, thank you so much, Shruti.
Thank you. My pleasure, Sam.
So just now, I've just spoken to Shruti, and it has been a very enriching and interesting experience talking to her. right now we're at the Spintronics lab. So it's my first time coming here and really excited to know what is there here. So come on, let's go and check it out. So guys, here we have is William. So today he'll be sharing us more about what he does in this lab. But first things up, it's my first time coming here and I noticed that the room is so yellow. Could you explain why is that so?
Yeah. Why it's so yellow is because we want to prevent UV light from coming in. Reason why we want to prevent UV light is because we handle some of those chemicals. Some of those chemicals will change properties upon exposure to UV light. So that's why yellow.
Oh, I see.
Yeah.
So just now I saw you're doing some work. Could you explain what kind of work do you do in this lab?
Yes. So essentially what we do is generally we fabricate things like a hard disk or transistors or RAM, 8 gig RAM, 16 gig RAM, those kind of RAM. So essentially what we do is we start with a disk. So this is a silicon wafer. Silicon wafer on the atomic scale is very flat. So what we do is, because silicon is not magnetic, right? We're talking about fabricating spintronic devices. We need it to be magnetic. So how do we make it magnetic? First of all, we need to spray some of those magnetic particles on it. So how do we do that is with that machine.
Oh, okay. Showing it in there now.
So what this machine does, it does something called magnetron sputtering. What you do is you put this wafer inside this chamber, and then you put some maybe iron, cobalt, or nickel, one of those magnetic materials inside, and then it will spray those iron, whatever, those magnetic particles inside, and then it will become magnetic. So after it becoming magnetic, we need nanopatterns. We need to make nanopatterns out of it. So nanopatterns are essentially just patterns that are very, very, very small. How do we do that? We start with that.
Okay.
Let's go.
Let's go.
So this is called a spin coater. What you do is you put a wafer on it, and then you put some chemicals on it, and then as the name suggests, spin coater, right? So it spin. So after some chemicals are on it, it spins, takes it on a merry-go-round, and then it will spread themselves evenly, relatively evenly onto the wafer. And then after that, we can make some nanopatterns. So in order to make nanopatterns, we need something called lithography. So as the name suggests, lithography just means printing. To print something, we need a printer and we need an ink. The ink is the chemicals in this case, and then the printer is over there.
Right.
Let's go.
Show you how the printer now?
Yep.
Right.
So this thing does something called optical lithography. Optical lithography, essentially you just put this wafer inside, and then you program whatever patterns you want here, and then you would create some very, very small version of those patterns, nano patterns. So then after that you have yourself a transistor or a RAM or whatever, you know. So yeah, essentially that's what we do.
Alright, thank you William for that interesting sharing.
Yeah, you're welcome.
Alright. So just now we have spoken to William on what kind of work he actually does in this lab. And it was a very interesting time talking to him and learning more about it. Thank you for joining me on this lab tour. Be sure to check us out on our NTU SPMS Instagram or Facebook page.